Okay, so quickly go over the homeworks from 4.3. That was about linear independence. So let's go. The one that I assigned was 2a, and there he gave us three vectors. The vectors, and you had to show whether it was linear dependent or linear independent. So we had the vector. Let me write them up. What they are: -3, 0, 4, 5, -1, 2. And the last one was 1, 1, 3. So these were vectors in R. We are now working R3. And one thing that you can use to prove dependence, if you have in three vectors, you have vectors of size 3, and you have exactly 3 of them, then to show that they're linear dependent or independent is actually shown that the corresponding matrix, so if we build the matrix, and we'll see this in the lecture today also a lot, is you make the matrix, but remember, the vectors are always realized as columns. Okay, that's important. Don't mess that up. Okay, so these become our vectors now, our columns, and so we get a matrix, and so what we need to show is the determinant 0 or not. If it's 0, it's linearly dependent. If it's not 0, it's linearly independent. And the whole thing comes from the fact that this is the matrix that expresses the linear system of equation that you have to check for linear dependence. Okay, go back to the notes to see where this comes from. So, in other words, this is just a matter of calculating determinant. Now, let's do this. Okay, perhaps it's good to do is an example where we don't have a pivot right away where we would like it, but I'm going to show you it doesn't really matter. So I'm thinking of using this as a pivot now. There's no good row to, you could of course use row 2 to expand, but let's minimize our calculations. So I'm going to use this pivot. That means the two operations that I have in mind are, where should I write them here? So to do this and this one, right? So that's the point now, right? I'm using this one to make a 0 here and the 0 there. Okay, it's always underneath the pivot. Oh, no, well, in the same column as the pivot. Sorry, I should be more clear. Okay, so, sorry, R2 is obtained by R2 minus R1, and R3 is obtained by row 3, subtracting 3 times row 1. Okay, so we get, the first row is not touched. So we get -3, 5, 1. So now we subtract this row from that row, so you get, so it's better to say multiply -1 and add. So -1, -3, that's 3. -5 plus -1 is -6, and that is 0. And now we multiply with -3 and do the same thing with the last row. So 9 plus 4 is 13. -15 plus 2 is -13, and that is 0. Okay, this gives us the one there that we can use for expansion. We always have to be sure that we have the right sign. It's a plus sign, so we use column 3 now. So we get 1, well, I'm writing the 1 plus 1. Okay, it's kind of silly to write, but I'm referring to this plus and this one, right? Okay, and then the determinant left is 3, -6, 13. -13, now might be a little bit calculation, but not that bad. That is -39 minus 78. Now, whatever it is, it's not 0, okay? Which means, therefore, linearly independent. And if you already looked at the lecture of today, or if you're going to see the lecture of today, you'll see this actually means, in fact, that we are here dealing with a basis of R3, okay? Okay, that's 2a. Then the other one was 3. That was 2a. What about 2b? 2b, there were 4 vectors given in R3. And then you can immediately say, well, they have to be linearly dependent, because there are too many of them. If you put these 4 vectors in a matrix, you get a matrix with a 3 by 4 matrix, and such a matrix will always have a free variable when you row reduce it, and therefore we will always have more solutions, whereas for linear independence we should only have one solution. And when I'm when I'm talking here, what I'm talking about here is of course about the homogeneous equations. Okay, so that's 2. 3. In 3, they ask the same question, 3a, I guess, right? No, 3b, I said 3b. Okay, 3b. Same question, but now we are in R4. So I'm going to write down already these guys. There are 4 of them. And so again, because they're the right amount, I can make a square matrix. I need a square matrix if I want to calculate the determinant, right? And then calculate the determinant of this matrix. Okay, so, and then remember, these vectors are put in here as columns. So that's what we get. Double checking that I don't make any copy errors here. Let's see. 3b, right? Okay, I think I got it right. So again, we don't have enough zeros to expand. We can use this one. We could also factor out something. Yeah, by the way, so I should make it clear, right? We're actually calculating a determinant here. So what we're doing is actually this. Okay, so I'm just factor out 3 in column 1. I'm picking this one because then I get a 1 in the top, and that's exactly what I want. Okay, so we get 3, that factor, right, that we get, and then divide each element in this column by 3. 1, 0, negative 1, 2. And that's the only thing that we do. The rest is just copied. I could, by the way, do this here too, but let's not do unnecessary steps. Perhaps we'll do it later, perhaps we don't. We'll see. Okay, so I have now my pivot that I'm going to use. As usual, I do the row operations, making these two numbers 0. So the row operations are going to be row 3 plus row 1, and row 4 minus 2 times row 1. I get, don't forget the 3 here. 3, and then 1, 0, 0, negative 2, 0, 2, minus 2, 1. So what I'm doing is adding this to that. That's 0, 3, negative 2, 0. And then adding, multiplying this with negative 2, this row, and then adding it there. I get 0, 1, 0, negative 5. Okay. So I have my pivot here that I can use expansion. So this is column 1 expansion. And I get 3 times, we know it's a plus sign, 2, negative 2, 1, 3, negative 2, 0, 1, 0, 5. Yeah, you see calculation of determinants is always this row reduction, constantly working with this row reduction. Okay, so make sure that you understand how this works. Okay, I have a pivot here again in the first column, so I'm happy with that. I'm gonna use that to make these two top guys 0. So the row operations I have in mind are now row 1 minus 2 times row 3, and row 3 is row 2 minus 3 times row 3. So I get, copying my 3, so this is 3, and then okay, so what am I doing? Multiply this with negative 2 and add up. So I get 0, negative 2, negative 10, so negative 9. Now I multiply with negative 3 and add up here. So that is 0, minus 2, minus 15. And then I have 1, 0, 5. Okay. And again, we now do expansion along column 1. Using this pivot, double checking my signs, plus, minus, plus. Okay, well, after a while you kind of know where they are, but just double check always. Okay, so we have 3, and then remains is minus 2, minus 9, minus 2, minus 15. And whatever this is, I know it's non-zero, because in a 2 by 2 matrix, they can only, if these two rows are different, are not a multiple of each other, which they are not, then. But okay, if you don't believe it, let's work it out. That is 30 minus, and then this is 18. Okay, this is non-zero. So again, linearly independent. And again, in the terminology of what we learned today, 4.4, this is actually the basis. Okay? And then finally, The last one was 9a. So here, now, okay, so this, so far we were checking a matrix, right? But this is a case where we cannot do this anymore because we only, let me write down, we have three vectors given to us, 0, 3, 1, and negative 1. The second one is 6, 0, 5, 1, and the third one is 4, negative 7, 1, 3. Why? So this is now, where are we? In R4. And so if we put them in a matrix, what we get, well, let's put, we'll still work with this matrix always, right? So what we do is we build this matrix here by using these, keep reminding you, as columns. Okay, but now we cannot take the determinant because it's a 4 by 3 matrix, okay? And so what we need to do, remember what it is that we're really checking. We're checking that this equation, this system of equations, which is the homogeneous system of equations, this equation should have only one solution. And we know already one solution we know for sure. Take x1, x2, and x3 all equal to 0. But there should be no other. Sorry. Don't worry, this is just a piece of some nuts that I eating was coming around throat. Okay, so but what we do is, what we need to show is we have a homogeneous system of equations, which means we have this extra column of zeros here, but let's forget about that column. Really, we need to show that we have no free variable. That's really what we need to show for linear independence, okay? So linear independent means that there are no free variables, because if there are no free variables, then there is a unique solution. Okay, so we have to row reduce here. Now, we're not calculating the determinant, so let's be a little bit more careful and get really the row reduce form. And so I need a pivot in the top part, which I can do by exchanging these two. So I'm going to do row 1 exchange with row 3. So the new matrix is then 1, 5, 1, and of course, in the back we always have zeros. I keep copying it, but it's not really necessary. And then 3, 0, negative 7, 0, 6, 4, and the last one is negative 1, 1, 3. Okay, so now I have a pivot. I need to do row operations with this. Row 2 is row 2 minus 3 times row 1, and row 4 is row 4 plus row 1. Okay, hope you see why. What do we get? I'll write it here. No, I'll go underneath here. Space. 1, 5, 1. So negative 3 and then add it up there. That is 0, negative 15, negative 10, 0, and nothing here. Okay, and then what else? Yeah, adding. So now we just add this row here is 0, 6, 4, 0. Okay, okay. So we are what we want. Unfortunately, now so we have the first pivot. The next pivot will be in this column. We have to look for it now. In other words, it must be coming from one of these three elements, right? Not from the row. This row is now already done and dealt with. We're not going to touch it unless we want to go back to our row, the reduced echelon form, which is in the second stage, but that's not necessary. Now, okay, there is no 1. That's a little bit of a pain, if you want, but we can divide out some things. Unfortunately, okay, let's make a 1 here by dividing, well, I could do the second row, but let's take the third row, less negative signs here, divide everything by 6. It's going to introduce fractions, but okay. So the row operation that I said was in mind is 3 by 1/6 of row 3. So we would have 1, 5, 1, 0, 0. Well, I could do that. Okay, let's not do this. Okay, I changed my mind because I'm a bit lazy and I saw if I do, although it's a slightly bigger fraction, I'm gonna actually divide row 2 by -1/15. Because then I have at least my pivot on the right position already, okay? Perhaps I was smarter. So -10 divided -15, that is 2/3, I hope you see that. And then this is just 0, and the other ones are just copied. So 0, 0, I want to do this in black, 0, 6, 4, 0, 0, 6, 4, 0. Okay, we got our pivot, and the row operations that we now need to do to make these two guys 0 are row 3 minus row 3, replace that by row 3 minus 6 times row 2, and row 4, same operation. Okay, we do this. So I'm multiplying this with 6, right? Okay, and then added both there. So what do we get? Well, this doesn't change. The 0 is in the back also, not 1, 2/3, 0. And then, okay, so sorry, with -6. So multiply this with -6, 0, that's 0. -6 times 2/3 is actually -4 plus 4. Oh, that is 0. Okay. Now, of course, the second row is the same, so also get zeros. So where are we at now? We have 2 pivots, and the rest are 0 rows, so there are no more pivots. What does this mean? This means there is a free variable. So we have here so these are the pivot variables, but more importantly, this is the free variable. So we have a free variable. And what does this mean? Remember, linearly dependent. Because there are now more solutions to this homogeneous system of equation. Okay? No free variable, then you are linearly independent, but we have free variables, so you're linearly dependent.